Study 4 to 6. I did not teach anybody 4 to 6, but I was too tired, so I got sleep. Otherwise, I planned to teach you study, but too tired, so that I slept.
Okay. That's a nice.
Huh. So geometrical isomerism in cyclic compound. That is, it is also that is, it can be of the cis or it can be of the cis. Okay, fine. So, hmm, so suppose this compound is there, right? If the both groups, suppose this group are there, both X is there, XX, same sign. So this is going to be what the cis form. Another word, suppose this is there. This is YY. So this is called cis form because similar side they are going. But if suppose this compound, if I am making the diagram, here is this you can draw the X. And then another X it will be here. So it is going to be problem now. Y, another is Y. So this is what is going to be trans. This is also. For example, if I am making another compound, let us see. I will ask you which is cis and which is trans. You just reply. This is the compound is there. Here is CH3. This is CH3. Here is H and here is H. And just little bit, you see this one. This compound. Okay. So now this is CH3 is there upside and downside CH3. Here is the hydrogen and here hydrogen. So the question is which is cis and which is trans? Hmm?
Sir, the first one is cis, second one is trans.
First one is cis. What you will write the name? Cis. You need to count 1, 2, 3. So you will write that is cis 1, comma 2. This is the dimethyl cyclopropane. 1, comma 2 dimethyl cyclopropane. Here is 1, 2. So 1 trans, it is going to trans. 1, comma 2 dimethyl. Dimethyl. This is what? Cyclopropane. Can you understand this one? Tannoy?
Yes.
One more example I am giving you. Compound. Here. You just try to tell me. Suppose this is Cl and H. This is there. And here is again Cl and H. Remaining places, there is no change. This is the HH is there. And here is also no change. This is HH is there. Similarly, here if you are going to get the idea about this one, they are saying this is Cl, this is H. Here is H, this is Cl. Here is the no change. Hydrogen, hydrogen. This is hydrogen, hydrogen. Yeah, which is cis, which is trans. Which is cis, which is trans.
Sir, here
Hmm.
CLHA.
Hmm.
Sir, the first one is cis, second one is trans.
Both the similar group are above the plane. Okay, Cl are the above the plane. Okay, and here is Cl above the plane and Cl below. This is the below, and this is the above. Because this structure is what? This is the plane, planar structure. So one is up, another is down. So this is going to be trans. So what you are saying that is correct one. This and this is trans. Okay, this is there. There are many compounds are there. Let me ask you one more. One more. Here you see. This is, if you see, what we are going to do, this is the cyclo pentane. Now, here is the this one towards the observer. Solid dash line is towards the observer. Suppose you are watching from here, and
Hmm.
another is there. Both line are towards the observer. Both the lines are towards the observer. Okay, towards the observer. Now, this is the CL and this is the CL. Now, another diagram when you are making this, you see. So this is CL and another one is there here with me. This is the again going to be CL. Now, it is the away from observer. Dash line, so no, with dash line, this is the away from observer. It is towards the observer. It is towards you and away from you. Away from you. From you. You can also understand, you can say it is below the plane, above the plane. So which is going to be cis and which is going to be top?
Sir, that one, sir. So the first one is this, second one is done.
So this is going to be cis and this is going to be top. Now, let me tell you one more. That is the both.
Sir, previous slide one, sir, please.
Oh God.
So done. So done.
Okay, okay, okay. Thank you. Let me tell you one more questions I am taking from the complete one loop. Okay. Hmm. This one is also they can see center. In the Akash test series, this type of question also they have given. Whatever type of question given in the Akash test series, that will be the most probable to come in the exam. This is the board form, and a chair form, not board. Chair form of cyclohexane. Cyclohexane found in the two form. One is the board form, another is the chair form. This structure is chair form. This structure is chair form. What is the board form if you are writing? Board form is something like that. This one. This is the board form. But if we are
So
studying
this is a form, sir.
cyclohexane, this is there. Board form, this is the chair form. It is looking like chair, na? This is chair. And this is board. 1, 2, 3, 4, 5, 6. This is cyclohexane, nothing but cyclohexane. Cyclohexane is not having the identical. This structure is not, this is cyclohexane. But in the chemistry, cyclohexane exists in the chair form and board form. So that we will study.
But normal sir, ring form that is not there.
What? NCRT, it is not there. NCRT, whatever we are studying.
No, no. Sir, I am saying that there is one form now which looks like this.
Hmm, 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 hmm.
This one. Sir, the ring one, sir, that is not existing.
This is not the correct one. Either it exists in the board form, either otherwise it exists in the chair form. Okay, at different temperature it exists differently. Now you see the here is there CH3 and another is there. This is also CH3. This is CH3 and this is CH3. Another is there, another compound. Here is CH3 is there and this is CH3. Or the same structure you can draw differently also. This is CH3. This is CH3. Right? No. Okay. That's CH3. Both are the similar one. That is, I think the mistake. is thinner. All the structures got removed. This is what for making you understand. I'm just making the diagram. It 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 can be of like that. We can mention not with this color. Otherwise, here. So you let me know which you are thinking to be cis and which you are thinking to be trans. Tell Sanoy.
Sir, first one is second one is 12.
Hmm. So first one is going to be cis and second one is going to be trans. Okay. This I am removing. Now we are going for the optical isomerism. Here is the optical isomerism. Isomerism. What is there? Everything are the similar are there. Okay. First one. No, it should have, it should have, it should have. It is the part of 12th standard, but I am teaching here. It should have asymmetric carbon. Asymmetric carbon. Asymmetric carbon that is there 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 must not be symmetry. What do you mean by symmetry? Molecule cannot, that is molecule cannot cut into two equal parts. Two equal parts.
Sir, how can one atom be asymmetric? So you are writing asymmetric carbon.
Uh,
Because one atom cannot be asymmetric in itself.
no, asymmetric carbon means carbon is having four na. Carbon means what? Carbon compound. You see, carbon compound. Carbon compound. Wherever carbon is there, it should have the four valency. Carbon, can the atomic form carbon exist? No. Atom are the unstable form. It will exist in the molecular form. Okay. Carbon should be should be chiral. 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 That is that is contain four different groups. That is contain four different groups. It must have four different groups and must be sp3 hybridized. Carbon should be chiral, that is contain four different groups and must be sp3 hybridized. This point you need to remember that.
Sir, done.
Done. Okay. So what we are going to do, we are going to have the example of see third point. These compounds, these compounds, these compounds should not be, should not be superimposable, superimposable on their mirror image, on their mirror image, MIRR, mirror image. They cannot be superimposed. Second one, okay, uh, they are, they are differ in, they are differ in rotation of, they are differ in rotation of plane polarized light. plane polarized light. Rotation of plane polarized light. Okay. Case 1. If compound rotate, if compound rotate, if compound rotate, CPL into left. Yeah, right. CPL into right direction. Right direction. Then it is deformed. Then it is deform OI. Deform OI. Also called dextrorotatory. No, deform OI. DEXRO. Dextrorotatory. ROTATORY. Dextrorotatory. Case 2. If compound rotate in left direction, if it is rotating PPL in left right direction, then it is L form. Then it is L form. OI. That is called LAE, levo rotatory. Levo rotatory. If the compound is rotating, what direction? Right direction. That is called deform. That
So
is
right, then it is dextrorotatory. It is left side, then it is laboratory.
thank you very much. Okay. Firstly, you make a note. If you are understanding, that is very good.
So
Otherwise,
done.
otherwise it will come again in the 12th standard. It will also come again, and some more places it will come. Right. So now we are going to do the sum of the problem. What we can do here? Taking the one more page. Okay. So 4 different group. sp3 means what type of structure? That should be tetrahedral structure. Right. I am taking OH group, H group, S3 group, C2H5 group. Is it the having this carbon is sp3? 4 different bond means sp3, 1s, 3p. This is chiral, 4 different group. If you are making the image of it, this is the mirror. This is the mirror. So what the image you are going to get? So this will be CH3. Here is C2H5. And here will be something H. And here will be OH. If you take this one and put on this A and B. If you are putting this one, this OH is here is right side, here is left side. So they cannot be imposed. So they are non-superimposable. That is non-superimposable. Non-superimposable. That is also non-superimposable. So if they are non-superimposable, it will rotate that is light into the clockwise. Clockwise. Clockwise means right direction. So that is deform. Deform OI. Now this one is rotate into the left direction. So L form OI, optical isomerism.
Sir, how you are deciding that which one will rotate left direction and which one will rotate right direction?
That we will have to study the CIP rule. This much is not there. This functional group will decide. Functional group is there. Which direction is there? Right side. So it will go left. Here is left side. So it will go right.
So done.
Done.
Yes, sir.
So this is the optical isomerism we also finished. Now what we have to do? the reaction intermediate. Reaction intermediate. This must have taught in your school.
No, sir.
Reaction.
Sir, in my school, actually, hydrocarbons they have taught.
What?
Sir, hydrocarbon, the next step.
Acha, hydrocarbon. GOC not finished till now.
No, sir.
Okay. Mhm.
Sir,
So,
hydrocarbon will come in our test also, sir. This periodic test 2 is coming on, sir, December, starting from December. So that chapter will be there.
okay. But let us try to know the what is the reaction intermediate. They are formed. They are formed. They are formed during the chemical reaction. During the chemical reaction. During the chemical reaction. They are formed during the chemical reaction. No, we are preparing. We are no reaction intermediate means they are going to form during the chemical reaction, right?
Yes. Yes, sir.
So like that. One second. Huh. So they are formed during the chemical reaction. Okay. And they are intermediate means no after the reactant before the product. Okay. So here you see here what are the species are there in this state in this state formation. What the point we have to you? Formation and breaking of bond can be represented. Represented. Can be represented. Can be represented. Right. Formation or breaking of bond can be represented. So first of all, we have to know that is no fission of covalent bond. How the fission of covalent bond take place? Fission of covalent bond. Covalent bond. So fission of covalent bond are two types. Covalent bond during the chemical reaction, what is there? Old bond breaks and new bond forms. So that is homolytic fission. Homolytic fission. This will be the homolytic fission. And second one is heterolytic fission. Heterolytic fission. They didn't teach till now this one. In your school, this is taught or not? Homolytic, heterolytic.
Okay, okay.
Not taught. Homolytic. Each atom, each atom, each atom acquire one electron. Acquire one dash one electron. Each atom acquire one dash one electron. Formed species is free radical. Formed species is free radical. Species is free radical. Free radical. Here you see heterolytic fission. Both electron, both electron goes to one atom. Goes to one atom. One atom. So that become hetero. And second one, formed species are what is carbocation, 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 and carbanion. One will be the negative charge, another will be positive charge. Here will be free radical, dot will be there. So fission means what? That is breaking up the covalent bond. Breaking up the bond is called
Carbocation, sir, what you have written below that one?
carbanion. 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 Nion. Carbanion. Carbanion.
Yes.
That is also called carbanion. So here you see,
Yes.
uh, here you see, we are taking the homolytic figure. Homolytic. Homolytic. suppose what are there? We are having a compound CH3. I am making Cl, and you need to give the sunlight. Okay, sunlight. So in presence of sunlight, it takes place, or peroxide, homolytic fission. Two conditions are there. Either you supply the sunlight or you supply peroxide. There is no other condition to form. Otherwise, it should have the one more free radical. Okay. So what will happen? Homolytic fission. What will happen here? One electron will go here, another electron will come here. So what will it going to happen here is CH3, 1 and Cl. This is the also free radical dot. One electron is dot. So this is what is called methyl free radical. Methyl free radical. Here is chlorine free radical. Done.
Yes, done.
Okay. Next one we are going to study the point degree of free radical. Degree of free radical. Free radical. Okay. So what is there? First one is methyl free radical. Methyl free radical. Free radical. First one is methyl free radical. This is the first. Second is 1 degree. Third one 2 degree. Third one, fourth one is 3 degree. Okay. What is this one? This is also the example of 1 degree only. So both I am describing. If free radical carbon, if free radical carbon, if free radical carbon, that is alpha carbon attached with alpha carbon attached with one more carbon, or no more carbon, no more carbon, no more carbon directly, no more carbon directly, called, called, what is there? Called 1 degree free radical, 1 degree free radical. Now, so it is very easy to understand. Here is CH3. So this is going to be alpha carbon. So alpha carbon is attached with no more carbon. So this is 1 degree. Directly, the word is used directly, not indirectly. Here you see CH3, CH2. So this is there. So if you see, this alpha carbon is attached with one more carbon directly. So again, it is going to be 1 degree, and this is also going to be 1 degree. Next one you see CH3, CH2, CH2, and this is. So this is again the
So 1 degree.
1 degree. Yes or no?
Yes.
Are you getting this one? 1 degree. Directly one
Well,
more
it is.
carbon or no carbon. So that is 1 degree. Now, if you are talking 2 degree, so alpha carbon attached with two more carbon, attached with more carbon, two more carbon. Alpha carbon attached with two more carbon. So here is, suppose here is CH3, CH3. What is there? Here is alpha, here is hydrogen is there. So this alpha carbon you see attached with two carbon, yes or no, directly. So it is going to be 2 degree. Can you understand?
Yes.
What about this 1 degree? Can you tell me? What degree is the second one? Hmm?
So this is also
2
2
degree.
degree.
Directly this and these are attached, na 2. This is the indirect one. This one is indirect, that we don't have to consider. 3 degree, 3 radical, 3 degree Kelvin. So alpha carbon attached with 3 more carbon, 3 more carbon, 3 more carbon. So if it is attached with 3 more carbon, so what is going to be if alpha carbon attached with 3 more carbon? So example you can write like that. So here is CH3, this is CH3, this is CH3. So this is 3 degree. Is it okay?
Yes.
Can I erase?
Yes.
Now, heterolytic fission. HET, heterolytic fission. So whenever you are talking about heterolytic fission of the covalent bond, so what you are going to have? Heterolytic fission of the covalent bond. What you are going to have in this case? So CH3, suppose I am taking H. So which is more electronegative? Hydrogen or carbon?
So is there the hydrogen is
Hydrogen, how can be more electronegative? Group 1 element and carbon is group 14 element. Left to right electronegativity increases. Its electronegativity is 2.5, its electronegativity is 2.1. Electronegativity is tendency to attract the electron. So if you are giving the heat, so both the electrons, 2 electrons are there, both will go on the carbon. So in this case, it will form what is what? CH3, C, this is CH3, this is CH3, and this is the negative charge, plus H plus. So this is what is called carbanion, 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 right? So what do we mean by this one carbanion? Negative charge on the carbon. Now let us see this one. Suppose I am making this one Cl. Now, which is the more electronegativity, carbon or halogen? Here you are supplying heat, not the sunlight. So both the electron will go on the chlorine. So it will form the CH3 plus, depending on which one is electronegative. Okay, this is called carbocation. The both the electron will go on the more electronegative atom. So if you considering carbon and chlorine, so carbon will be less electronegative, chlorine will more. So it will go. If you are breaking this one carbon hydrogen bond, so electron will go on carbon compared to hydrogen. So negative charge on carbon and here is positive charge on carbon. So if negative charge on carbon is there, so that is what is called carbocation. And negative charge is on carbon, that is called carbanion. Hmm. Done.
yes. That.
अब types of carbocation and carbanion. Carbocation and carbanion. So here you see, this we are going carbocation. This is carbanion. Carbocation, this can be also, 3 types are there. Methyl, first one is methyl. Then 1 degree, 2 degree, 3 degree. Suppose this is the CH3. This is again going to be 1 degree only, but it is methyl. If you are having CH3, CH2, here is positive charge, again 1 degree. If you are having CH3, CH, CH3, here is positive charge, 2 degree. And if all the cases, here is what is there, CH3, So this is the 3 degree. CH3 minus carbon ion 1 degree. CH3 CH2 minus 1 degree. Minus 2 degree. 3 degree. Are you be able to understand this?
Yes.
Put down heading. Can I read?
No, no, sir. Please keep this time. You're done.
Okay. Sanoy, put down heading and leave the class. I got tired now. Total my mouth is paining after speaking long time.
Okay.
So what you do, that is you need to study physics also today.
No, sir. Sir, that is in the night.
Okay. Stability of intermediate.